Hello, this is Harsh Swaraj, MSP third year, IIT Roorkee. Today I'll be presenting on the topic how to determine the mode of given array of numbers. This is done under the coursework of course PSM 4 microprocessors and peripheral devices. Okay, now I shall give you the overview. I will introduce introduction, then approach, flowchart, code, and then we shall give you a demo of the program made. Okay, the mode of the dataset. The mode of the dataset is the number that occurs most frequently in the set. The mode is easy to find for large datasets. Sometimes the dataset can have outliers which are very different from the rest of the data, and these can affect the overall mean. Hence, mode is useful in such cases because it is not affected by the outliers. Now, here for example, the given data, here the mode is 1 as it occurs maximum number of times, that is 3 times. Okay, now we shall talk about the approach we are going to take. Suppose our array is this 1, 2, 3, 3, 3, 4, 4, 4, 4, 4. The algorithm chooses an element one by one and compares it with each element to check if it is equal to the second element. Supposedly 1 will be taken and will compare with 2, 3, 3, 3, 4, 4, 4, 4, 4 to check whether it's equal or not. Now how it will be done? Here, 1 will be subtracted from all the elements of the array and will check the 0 flag to see if the element is equal to 1. Hence, the element 1 and its recurrence, which is once in this case, will be saved in the memory. Similarly, it will be done with 2 and 3. Now, the code will check if the recurrence of this element is more than the recurrence of the elements in the previous iterations. As we have seen in the previous slide, As we've seen in the previous slide, 1 was occurring once and 3 was occurring thrice. So the values will be switched. Now this is how the done in the iteration 1. 1 is taken and it is subtracted from each and every element. And if 0 is done, then 0 flag will be activated. In the second iteration, 1 will take 2 and it will be subtracted from each and every element. And if there is 0 occurs, the 0 flag will be activated. Now we shall explain the algorithm with the help of a flowchart. As we are talking about explaining the algorithm via flowchart, now we'll start. Initialize the counter. Store the 2060H data in HL. Choose element. Store at memory and store at 0000H. Now we shall load A with value at 0000H. Choose value stored at memory. Subtract value in E from A. Now if the answer is not equal to 0, then we'll decrement the inner loop counter at B, increment value in HL at memory. Now if B is equal to 0, not equal to 0, then we shall repeat the process. If it is equal to 0, then we shall proceed to the next step, which will be explained later. Now if here the answer is 0, then we increment the counter at D, decrement inner loop counter at B, increment value in HL that is memory. If the answer is not equal to B, then if the answer is not equal to B, that is B is not equal to 0, then we shall proceed, repeat the step all over again. If it is equal to B, then we shall proceed with the step load A with value at 2000H. Next, subtract D from A, that is check if the counter at D is greater than previously stored value of the counter. If D is not greater than A, then we should continue with the step here. But if it is greater than A, then store value at D into 2000H. Now, we should proceed to the step decrease C, that is outer loop counter. Next, go to the next memory location for A, increment H and store in 3000H. Now, if the C is not equal to 0, then we shall proceed to the step, that is here it is proved that the number does not have the counter value greater than the previous number. Well, and if it is greater, if it is equal to 0, then we load accumulator with value at 2000H. This process will be repeated at least the number of times the elements are present, the number of elements are present in the given array, and we shall halt. Thank you. Now we shall talk about the code. Here, data is stored from 2060H onwards. The final result with the occurrence of the data is stored in the 2000H onwards. Now, in the code, this represents the outer loop, this represents the inner loop. Next, we'll talk about the execution in the demo part. Start my comment. Okay, now as I spoke in the previous slide, we'll be explaining the demo. We'll be viewing the demo. Here the code is written as you can see in the slide, and we have entered the data from 2060 memory location onwards. Here you can see there are two ones, two rows. There is one 3 and four 4s and one 5. Now we shall assemble it. Now we shall execute P2, and now as we can see the solutions will be visible in a 2000H memory location. Here the mode is 4, and it is there 4 times. So that's my presentation. Thank you very much.